Okay, so the same example, um, we we used case 1 to find total kinetic energy is 75 joule, and we can also use case number 2 to find kinetic energy. So case number 2, we can use the fixed point O to find kinetic energy for this system. So based on our lecture, case number 2, you can put your point P on that fixed point O, then your equation for kinetic energy is simply 1/2 IO omega squared. Okay, so let's put down the equation here. Kinetic energy equals 1/2 IO omega squared. Okay, so here we're given omega. The only thing unknown here is this IO. However, we know the disk, for a disk, Ig, the mass moment inertia about mass center, equals 1/2 mr squared. How do we find the mass moment of inertia about point O? And that's when you need to use the parallel axis theorem. So IO equals Ig plus mass times dOg squared. So mass moment inertia about point O can be calculated using Ig plus mass times, this is a distance squared. What distance? It's a distance from point O to point G. And so we can plug in what is Ig, that's 1/2 mr squared plus mass times, what's the distance between O to G? Let's look at the diagram here. The distance between O to G is simply r. So that will give us r squared. So this will give us um, 3/2 mass r squared. This is our IO. Now we have mass moment inertia about point O. Can plug that into the kinetic energy equation. T equals 1/2 3/2 mass r squared times omega squared. And now we can plug in mass r and omega. Times 1 times 1 squared times 10 squared. And once you plug in everything, you will realize, and our result is 75 joule again. Of course, it's the same system, they should have the same kinetic energy. 75 in case 1, 75 joule in case number 2. Okay, so that's how do you use kinetic energy equation to calculate the total kinetic energy for any system.